So we're going to finish up section 3.4, remainder theorem and factor theorems today. So we'll kind of take care of the remainder theorem first. We've already done kind of this stuff, especially the factor theorem we've talked about already, but obviously our main goal is to be able to do these things today. We have done 3.4 in the past. It's kind of the part that I kind of just waited on so we could get the assessment in before break. We'll add this in there probably next week, middle to end of next week, probably for our next assessment. I don't know. We'll play it by ear here. Yeah, it has to be before the end of next week. Yeah. So the remainder theorems that we have today. So just kind of a little review. If we have f of x is equal to 4x cubed minus 2x squared plus x plus 5, and I ask you to evaluate f of 2. Okay, I'm asking you, go. We have f of x is equal to 4x cubed minus 2x squared plus x plus 5. I want you to evaluate that function at f of 2. So just a reminder, if you've forgotten anywhere you see an x in your original function, you're going to replace it with a 2. Give you about 45 seconds. Probably need a calculator for this as well. Make sure you follow order of operations if you do not have a calculator doing it for you. Answer you should have got. You should have got in highlighter 31, or not in highlighter. You still should have got 31. So remember when we do this, you'd have 4 times 2 cubed minus 2 times 2 squared plus 2 plus 5. And you do order of operations, you end up with 31. And now, this is something that we worked on early when we were talking about functions and evaluating functions and doing all of those things. And it's a great way to evaluate functions, but we can evaluate functions in another way using what we call the remainder theorem. Okay, so the remainder theorem says this, that the remainder of a polynomial divided by x minus k is equal to the function evaluated at k, f of k. But essentially is saying that we can use long division or synthetic division to find the answer that we just found when we evaluated that function at 2. And we can do synthetic division to do this. And our remainder of that, whatever our remainder is, that little box that we put at the end, that you would always put like 17 or 31 over x minus 2, that 31 that we have now that's going to become the remainder, that's the solution to this question. And we can do it by synthetic division instead of sometimes relying on the calculator to do that. So if we take this same question, 4x cubed minus 2x squared plus x plus 5. And we want to find f of 2. Now, a couple things to keep in mind. When you're finding f of 2, that's the same exact thing as saying x is equal to 2. Okay, these things say the same thing. Also says the same thing that our factor of this would be x minus 2. Is equal to 0 if the remainder was 0. We'll talk about that in a minute. But this question can be written in a couple different ways. You can say, what's our solution of f of 2? That's one way to write it. What's the solution to this if x is equal to 2? Or what is the solution to this if a factor of it is x minus 2 equals 0? So there's 3 different ways you can answer this. And we're going to use synthetic division to do this. So when we use synthetic division to do this, we're going to go inside of our box. Now, here's where everybody gets confused, is we've always said it's the opposite of. Well, it's the opposite of it if it's in the form of a factor, x minus 2. Because we're asked to evaluate at 2 or x is equal to 2, we're actually just going to put 2 inside of the box there. Okay, so it becomes kind of exactly what you see instead of the opposite of what you see. And that's because they're giving you the value of x. When we were doing these before, we were given a factor of it, or to see if it was a factor of it. Now we're just going to do the synthetic division. So there's cubed, there's squared, there's to the first power, there's our constant. We drop the 4 down. 2 times 4 is 8. Negative 2 plus 8 is 6. 6 times 2 is 12. 12 plus 1 is 13. 13 times 2 is 26. We have a remainder of 31, which is what we wanted to happen because we said initially when we evaluated at f of 2, our answer was 31. The remainder theorem says that has to happen because our remainder is going to be the exact same as that. And this works all the time. Okay. So it's a different way to solve an equation given where we want to solve it at. Okay, so if you have these huge long things that get confusing when you put them in calculators, you don't have to. You can do the synthetic division. Plus, it gets you a little bit better at your math facts as well. So if we have x cubed, so let's look at a couple. We'll look at 3 examples. So we've got x cubed minus 10x squared plus 25x. We want to know what's the solution for f of 1 or x is equal to 1. Okay, so we're looking for the solutions, and we're going to use synthetic division to do this. So again, inside of our box, when we're doing the synthetic division with these, is in highlighter again, we put exactly what we see. We see a 1. So that 1 is what goes there. Now we count down. We've got 3, 2, 1, and none. Make sure you account for all of them, including the none. So we need to put the 0 in there, even though there's not a constant. We need to put that 0 in there. We draw our line. Bring down the 1. 1 times 1 is 1. Negative 10 plus 1 is negative 9. 1 times negative 9 is negative 9. 25 times negative 9 is 16. 1 times 16 is 16. 0 plus 16 is 16. So our solution for f of 1 is 16. And you're done. If all they're asking you to do is find the solutions for them. The solution is going to be whatever your remainder is using the synthetic division. Go ahead and do that one. So you've got 11x to the 4th plus 3x cubed minus 28x squared minus 12x plus 4. Find it for f of negative 2. So in the side of the box, you've got negative 2, 4, 3, 2, 1, none. So 11, negative 22, negative 12, 24, negative 4, 8, negative 4, 8, 12.
Yes.
Okay. So f of negative 2 is 12?
Yep.
Are you okay so far? Okay. Let's go ahead and do this one. So we've got f of x is equal to x squared plus 5x. Go ahead and evaluate that at f of negative 5. Guys, stop. Stop. So we got 0. So f of negative 5 equals 0. We okay? So we've talked about this quite a bit. What happens if we get a 0 as a remainder? What does that mean? What does that mean? If we had x plus 5 and we divided x squared plus 5x, and I divided that by x plus 5, and I got a remainder of 0. What did we say about the x plus 5? It was a factor of it. Okay? So if you get a remainder of 0, this actually means that x plus 5, another way we could write this is x plus 5 equals 0. Because x is equal to negative 5, add 5 to both sides. Okay, so x plus 5 is actually a factor of this. And it's going to be a factor of this anytime we get a remainder of 0. Okay, and we've talked about that quite a bit. We didn't talk about it in the sense of x is equal to something. We did talk about it when it was something like this. And this is actually a theorem. This is actually called the factor theorem. What the factor theorem says is it states the expression x minus a is a factor of a polynomial p of x if and only if p of a is equal to 0. So if we end with the remainder of 0, whatever that x minus a is going to be, that is going to be a factor of the polynomial. So in the above one, we had x equals negative 5, so we had x plus 5. So x plus 5 was a factor of that polynomial. And again, we've talked about our long end goal for this chapter is to be able to graph these polynomials. In order to be able to graph these polynomials, we have to find out where they cross the x-axis. Well, that's the zeros. So we have to be able to factor these. So this then becomes the next step in saying, okay, are they actually factors of it? Okay, so let's look at an example. So if I have p of x is equal to x, 5, let's try this again. P of x is equal to x to the 5th minus 5x cubed, be careful, plus 9x squared minus x plus 3. I want to know this time if x plus 3 is a factor of it. So if I'm asking it's a factor of it, this doesn't say x equals anymore. Okay, so in this case, what's going to go inside the box? Negative 3 is going to go inside the box because remember, we're asking if this is a factor of it. Okay, is it a 0 of it? So we put negative 3 inside the box. Go ahead and finish it. we got. Negative 21. So is it a factor of it? No. It's not a factor of it. It's only going to be a factor of it if that right there is 0. Since it's not 0, it's negative 21. I know x plus 3 is not a factor of this. I do know that f of negative 3 is negative 21. So I have another point on this graph if I am going to graph it. I've created another point on this graph that I can use. I can use the point negative 3, negative 21 to help me graph it, but that is not one of the factors of it. If I was going to factor this, and we're not factoring it yet, so this is a question that we'll see how you do. I know x plus 3 isn't a factor of it. Can anybody think of another factor that I could try? What's another factor that I could try to see if it worked? What? Why 1? It is 1, but why? It is 1. It's 1 or negative 1, but let's say it's 1. But you may know why would it be 1? There's 4 of them. I could use 3, negative 3, 1, or negative 1. What? That's right there, right? What do my last terms have to multiply up to be? 3, right? They have to multiply to be 3. So my last terms, whatever the factors are, it's not x plus 3, but if it was x plus 3, these two, they have to multiply to be that. Right? They might not work, but they still have to multiply to be to that. So that's why 1 would be one of them that we would try. We could try negative 1, we could try negative 3, we could try all of those to see if they're potential factors of it, and eventually you get to do that. For today, you just need to say no. Okay? So let's look at 2 more. So go ahead and figure out if x minus 4 is a factor of x cubed minus 10x squared plus 28x minus 16.
So should we do this 4 times with each of the numbers?
No. You just need to do with what I have. That's later. There's actually more for this one. Because you could use 1, you could use 2, you could use 4, you could use 8, you could use 16. This has lots of them that you would have to try. And we'll eventually do that. Both the positive and negative. It's fun. And then we change the value up front here, and then it becomes even more fun. Math is fun. You think it's yes because it's small? What goes inside? 4, 1, negative 10, 28, negative 16. Hey, how you doing? So we've got 1, 4, negative 6, negative 24, 4, 16, 0. Work? Yep. So x minus 4 is one of the factors. And then we would have something like x squared minus 6x plus 4 be your other factor. We'll get to that later. And then we can find zeros, and we can do a bunch of fun stuff with that. Last one. So now we've got 12x to the 5th plus 6x to the 4th. Minus 16x to the 3rd plus 23x squared plus 23x minus 16. I want to know if 2x minus 1 is a factor. Remember how do we find what we put inside that box? Set it equal to 0 and solve. This could be 1, 2, 4, 8, 16 positive and negative. 1/2 could be 1/4. Could be there's so many answers to this.
I don't even understand. Like, what do we do with that? What do we use those for? It's literally 1/2. Like, what if he's not good at those numbers
Is this a verb or a noun?
Remember when we did this?
So what goes inside the box? 1/2. Remember we set it equal to 0. Add 1, divide by 2. 12, 6, negative 16, 23, 23, and negative 16. Half of 12 is 6. Shh. Guys, ladies, we're almost done. 6 plus 6 is 12. Half of 12 is still 6. That's negative 10. Half of negative 10 is negative 5. 23 minus 5 is 18. Half of 18 is 9. 23, that's 32. Half of 32 is 16. Is it a factor? Yes. Since our remainder was 0, its factor, it is a factor. Questions with any of that? Are we able to find the remainder and figure out if it's a factor or not? Now, when you're doing your assignment today, make sure you read the directions. Some of them say, find the solution. Some of them say, is it a factor? And some of them say, divide. If it says divide, the answer is 12x to the 4th plus 12x cubed minus 10x squared plus 18x plus 32. Make sure you read your directions. It's inside.